Okay, we're going to calculate how much potential energy is stored in the gravitational interaction between the sun and the earth. So we need some basic data to do this calculation. So average distance between the earth and the sun is called the astronomical unit, and that's about 1.5 times 10 to the 11th meters. Mass of the sun, 1.99 times 10 to the 30th kilograms. And home sweet home, Earth, mass is 5.97 times 10 to the 24th kilograms. So this scale is obviously not correct, but just to point out in passing, 100 Earths would fit across the sun. So in terms of volume, 1,000,000 Earths fit inside the sun. And then the correct scale for distance between us and our star is about 100 suns would fit between us. So a little background information on how this basic picture would be more accurate if drawn to scale. But that wouldn't fit very well on a paper. All right, so we're talking about gravitational potential energy where little g is not constant. So we have to use the general expression. So two interacting masses, it is constant of gravitation times the product of the masses divided by the distance that separates their centers. We put in values for the sun and the earth interacting at a distance r apart. We have a minus 6.67 times 10 to the minus 11. And that's Newton meter squared per kilogram squared. Mass of the sun, 1.99 times 10 to the 30th kilograms. And mass of the earth, 5.97 times 10 to the 24th kilograms. And that's all over 1.5 times 10 to the 11th meters. And just checking the units quick. Kilogram is going to cancel out kilogram squared. I have 1 power of meter in the denominator. Cancel out that squared. So this is going to be an answer that's in Newton meters, which is joules. So that part works out. And that gravitational potential energy is minus 5.28 times 10 to the 33 joules. Now what does that number mean? Well, first off, the fact that it's negative means that we or somebody would have to do work to raise this up to 0. So this is saying that the Earth is gravitationally bound to the sun. We can continue to orbit around it. If we wanted Earth to be free from the sun's gravitational interaction, we'd have to pay an energy penalty of providing like 5.28 times 10 to the 33 joules to raise the energy of Earth to be at the level of 0. So it was free to move about and no longer bound by the force of the sun's gravity. So the negative sign is telling you that it's bound up in the interaction, and then how big this value is telling you essentially how much energy is currently stored in that gravitational interaction. Another thing I wanted to do in this video is go through just a little bit of notation that you'll sometimes see in my lecture notes, and you might see some other places that looks a little strange, but it's a nice little shorthand. So objects in our solar system, like instead of writing out mass of the sun, you might see that as capital M, circle with a dot, mass of the earth, instead of M sub E, circle with a cross. So every object, well, major object in the solar system has a little shorthand notation for what it is, and this goes back a long time. But just to step through them, the sun, circle with a dot. Next out is Mercury, so stickman with little horns on his helmet. Venus is the female symbol. Earth, circle with a cross. Mars is the male symbol. Hopping out into the outer solar system, Jupiter, sort of a funky 4. Saturn is a funky H. Uranus is like Mars' symbol but with a dot. Neptune is a trident. And then Pluto is simultaneously the capital letters P and L. So you'll see these sometimes as shorthand symbols for those astronomical objects in our solar system.